Welcome back. I'm Philip. This is episode 2 of our Fusion 2 series. We're going to jump right in, but I'll remind you, don't forget to like, comment, subscribe. If you want to support the channel, check out our Patreon page, patreon.com/PhilipHurlitz. Links in the description. Check out our Discord. We help each other out. It's good times. We're just going to continue on with the documentation because a lot of people seem to have been enjoying that based on the feedback I've been getting. So we're just going to continue on. So if you remember from the last episode that we spawned our player. So if we come over here and we hit play and we start shared client, boom, our player is in. All right, but now we need to be able to move our player around. So Fusion, Photon, they do give you some sample player movement scripts. We're just going to create these and I'm going to talk to you a little bit about them, explaining what's happening. It should be useful for you if you have never dealt with player controllers before and you've been focusing mostly on rigid bodies. So I'm going to copy all this. I'm going to note that the class is player movement. And I'm going to go to scripts, create a new one, C# script, and player movement. Let it compile. All right, here we are. And I'm just going to select all that. And I'm just going to paste what we got from Photon. So what's going on here? So we have our player movement class, and it is a network behavior. And really the only reason that we're using a network behavior here is because we're using this fixed update network. We'll talk a bit more about that later. Normally I would just use a mono behavior, and especially if I'm using with multiplayer, I actually really like using visual scripting. So I'll use Playmaker visual scripting with my Fusion integration that I built for it for Fusion 1 to do all my multiplayer stuff. But once this series is over, I am planning on updating my Playmaker integration to work with Fusion 2. So you technically wouldn't have to use a network behavior here, and the documentation talks a bit about other options in shared mode. But when it comes to server and host mode, you pretty much have to when it comes to movement. But we're just going to go along with this script for now and talk about what's happening. We have a reference to the character controller that's on the game object. And it's just, we need to make sure that this player movement script is on our player that has the character controller so it can get the component during awake. This is just the speed we want to move. Generally, I move at least at speed 3, but we'll see how 2 feels. And what this is doing is it's listening to see if there's any inputs on update. This is a special update called Fixed Update Network. And it talks about it right here in the documentation on handling button presses, that anytime you're handling a button press that's related to movement, you should do it in Fixed Update Network. And there's 3 different options you can use. And it says the above options only apply to shared mode, which is what this whole series is about. All right, so let's go back and look at our script and see how we're doing it over here. So first thing we always want to do is check for state authority. If we don't have state authority of this object, we want to return. Because if you keep in mind, whenever I join the room from our player spawner, anytime a player joins, if it's me, or I'm sorry, if a player joins, if this player is me, spawn my player object. But when you spawn a player object, it creates it across the network. So everyone sees it on their machine, which means this player movement script will also be running on that game object that I have spawned. It's going to be running for me and it's going to be running for everybody else. But it's going to be really confusing to everyone's machines if everyone's inputs control that player. So we only want the player who has state authority of that object to be able to control it. So every time the fixed update network tick happens, if we have state authority, we'll continue. Otherwise, we're going to return and not do anything else in fixed update network. So we create a vector 3 move script. And this is using the old input system, which I'm not a big fan of. I'm not a fan of at all. I love the new input system. It makes everything so easy, from handling if you want to do keyboard inputs, gamepad inputs, VR inputs. Just makes everything so easy. All right, but then it just gets that vector 3 move and then applies it to the controller. So the controller move will then move the controller. And it's taking that input times the runner delta time times player speed. So I've never used this, and I don't know if it just wasn't in the previous documentation or if I glossed over it for Fusion 1, but I haven't had any issues. But movement almost always is related to delta time, but usually you're doing time delta time. But what this is doing is because it's a network behavior, it can actually use the time from the runner, and it should, in theory, make movement across the network smoother and more in sync. So this, if you've written character controller movement scripts before, there's a slight difference here. So you're using runner.delta time instead of time.delta time. You're doing it in fixed update network instead of update or fixed update if you're using physics. And then this is the player speed from up here that we're multiplying by. So if the move vector is not equal to 0, then we're going to make the game objects forward. Oh, we're telling the game object to look at that direction, right? Yes. This is to make your game object look in the direction that you're moving. Look in the direction you're moving. And the reason that we check that it's not 0 is because then every time you lift up your input, your like W or forward, then your player is going to go from looking in the direction they're moving to looking back at like 0, 0, 0 or something. So I'm going to add that comment because I just think that's important. All right, so we can add this to our character, right? So if we go to network prefabs, player capsule, and we come over here, add component, I'm just going to drag it over, player movement, because I couldn't remember what I called it. Oh, what are you doing now? Oh, it's got to recompile because it was a prefab. There, we got it. All right, so if we hit play now, and it's going slower because it's still compiling. All right, start shared client. There's our dude, and we are now moving. And the reason we're hovering over the floor like that, if we go look in the scene view, and we look at our capsule, let's look at the floor. You know what? Let's go window, analysis, physics. Bring this down here. I mean, why did that stop? Why? There it goes. All right, so I have, I think my plane has a convex. Yeah, it's convex. But I still think, oh, yeah, that's what it is. If I turn off convex, then it probably wouldn't be like that. So let's stop. Take my plane, turn off convex, because it makes it like a 1 inch or a 1 unit tall cube centered on the plane. So let's try again. Make my plane not convex. And there we go. Now we're walking on it and we're moving super slow. I feel like our character needs something just to make sure everything's working here. So let's look at it in scene view. And let's look at its forward direction. Let's make sure, yep, we're on local. And we need to give this guy some eyeballs. So 3D object, cube. And we're going to go like, no, you know what? We're going to just scale it on the X. Nope, we're going to scale it on the Z. And then we'll scale it on the Y to like 0.25. And then we're just going to give this guy some eyeballs. Something like this. Super cool visor. You've never seen anything like this before. It's super unique. I've totally invented this myself. No one else has ever thought of doing this. And yeah, we'll keep it white. Why not? White shades. So now if we come over here and we play, we should, yeah, there we go. We're moving in the direction, or we're looking in the direction that we're moving. It's snappy, but totally works. It does, its movement is a bit weird because the values aren't instantly, here I'm going up left, I'm letting go. You can't see. I'm going down right, then I let go, and he's still rotating back. Not quite. It's weird. I feel like if it wasn't on fixed network update, that wouldn't be happening. Maybe it's because I'm not using a smooth look at. I don't know. But let's just continue on with the documentation. That's something to sort out another day. Let's look at jumping. All right, so the jumping is just going to be added to the movement script. It's interesting that they're doing jump in update, though. Oh, because it's using this first method here. So saying, hey, go ahead and query your button down in update, store it as a bool, but then don't use it until fixed update network, and then clear it at the end of fixed update network. So you're going to use it for game logic and then clear it at the end of fixed update network. So let's see what they did here. So in update, if the input get button down jump is pressed, then we're saying jump press equals true. They added this because I don't think this was in our original script, right? Yeah, because we weren't checking for if we were grounded yet. So if the controller is grounded, which is grounded is a built-in function of the Unity's character controller. Basically, it knows if there's a game object underneath it, and it's touching, and that's when it returns it's grounded. So if it's grounded, it's going to continue to, it's going to set its velocity to 0, -1, 0, which just kind of holds it to the ground. I'm surprised that they're not putting this actual movement. Oh, it's doing it down here. Okay. So if it's grounded, it's setting its velocity on the Y to 0, just to kind of keep it grounded, keep it on the ground. And then we're creating a new, I don't know why it's doing it that way, but whatever. Then we're basically creating a false gravity. So we're seeing our velocity on Y is our gravity value, which is a new input variable that we're putting up here, this is the traditional gravity value from Unity's physics. Also notice there's a jump force there. All right, so it's taking our Y velocity, and it's taking our gravity value times runner.delta time. But if our jump is pressed, that's our bool from up here. If our jump is pressed and the controller is grounded, meaning that we're on the ground, it's going to add to our Y velocity this jump force. Then we're going to move the controller with our move vector plus our new velocity vector times runner.delta time. This basically allows us to jump if there's a jump. It'll make us jump if we've changed our velocity on the Y. And then we still have our look vector, our looking happening right here, which could obviously be cleaned up from our test. But then it's setting that jump pressed value back to false. So what we're just going to do is we're just going to copy all this wonderful goodies, and we're going to put it into our movement script. So we're just going to select everything, paste. We lost some of our comments, but that's fine. And now we should be able to just go in and jump, assuming we have, does Unity have a built-in jump on spacebar? Well, we shall see. All right, I don't know if we have a jump. It does. There we go. We're jumping. Yippee. But we can also move while we're jumping, which is pretty common for jump games. Also, it's going to maintain, let's see if I jump and then move. Yeah, it does let me move while I'm in the air, but that's fine. All right. Now the documentation has us go ahead and do a build test, but we're going to wait because we're going to do the camera setup too. So for camera setup, what they are doing is they're actually creating a camera at runtime, which I don't think I've ever done. I'll either have a camera already in my scene, I'll have my character controller also already in my scene, I'll have my camera already set up with whatever logic it needs to follow that player character controller, and then I'll have my avatar spawn in and become a child of that character controller. Or I'll have, and I don't think I ever do it this way anymore. What I have done sometimes is I've had the camera already be part of my network player that gets spawned in, but it spawns in with the camera disabled. And then I have some logic that says, hey, if this is mine, turn the camera on. But I don't like that method. It's too easy to accidentally have too many cameras running and too many audio listeners and all that jazz. Oh, you know what? I was wrong. It says in this tutorial, the second approach is used, which have the camera as part of the scene. When the local player object gets spawned in, have the camera, or have it attach the camera to itself. So we're going to create a new script called first person camera, and it's going to be applied to what? It's going to be on the main camera. All right. So let's take a look at this. We're going to go ahead and just create the first person camera script. In script, right click, create C# script, first person camera. All right, we've opened it up in Visual Studio. Just going to paste over it. And let's go through this. So what are we doing here? So we have a transform target, which is probably going to be our player. We have our mouse sensitivity value. We have a float for vertical rotation, a float for horizontal rotation. And so what's going to happen is in late update, if we don't have a target, we're not going to do anything. If we do have a target, then we're going to take the transform position. So this is the transform of the game object, or of the transform that this script is on, which in this case is going to be our camera. So this thing's position is going to be the same as the target's position. And so we're going to get the mouse X and the mouse Y, and we're going to apply that to the rotation of the camera. So the vertical rotation, we're going to minus equal our mouse Y times mouse sensitivity. And what this minus equal does is it inverts the mouse to where if up is up, if you move your mouse up, you're going to look up. If you move your mouse down, you're going to look down. That minus wasn't there, it would be inverted. Some people call the other way inverted. I might have that wrong, but we'll see in a minute. And then on the rotation, we have a clamp here because we don't want to rotate too much, I guess. They don't want you to rotate too much here. So we're clamping the vertical rotation to range of minus 70 and positive 70. Oh, yeah, because we have the rotation here, and then we're going to make it to where we don't go too crazy. And we have a horizontal rotation, just mouse X times mouse sensitivity. And then we get use those values to actually adjust the rotation of our camera using a quaternion to Euler, using our vertical rotation and our horizontal rotation. And what's that 0 stand for? Oh, where it rotates on the Z. So we have our X rotation, our Y rotation. We're not rotating on the Z. But this should just work. Except that we need to tell the first-person camera what our target is. Let's just go ahead and put this on the camera anyways. Well, why that's doing that, we'll see. This is very simple. Yep, we're still with the documentation. We're just going to put the first-person camera script on the main camera. So main camera, first-person camera, drop it on there. There it is. So we're going to now open the player movement script, and we're just going to add these lines of code to it. I'll go ahead and grab this first one. Actually, you know what? I'm just going to copy this because I can hand type that. So let's go find our player movement. And I don't know, where do we want to put it? You know what? It doesn't matter. I'm just going to put it here, public camera, and then lowercase camera. And then we're not using it currently. I'm not quite sure how spawned is going to work, because I thought, well, I guess we're using a network behavior, so that's how it works. Okay. So if has state authority, oh, it did want us to have a capital C for camera. That's fine. All right. So if we have state authority of this object when it's spawned, then we're going to set the camera as camera.main, and then we're going to get the first person camera behavior from that game object, and we're going to set the target value to this game object's transform. So if we come over here now, and everything compiles, and we come over to the game window, if we hit play, and we start the shared client, it doesn't look like anything spawned, but that's because the camera is now on this goofy boy, right? So here we are. Oh my goodness, what's up there? What is that? Oh, I'm looking at my eyeballs. All right, but we're moving around now. It's working. But one thing I don't like about it is, and you know, this is I'm now looking behind me, but I'm not moving forward because moving the player is relative to the player, not to the camera. So that's kind of weird. But yeah, it is whatever. And one thing we should do is we need to add some trees. So watch me add some trees. Boom, trees. And you might be all like, Philip, what do you teach us your amazing art skills? I know it's really impressive, but I just don't have the time to do art tutorials. But now if we spawn our player, we can actually kind of tell that we're existing somewhere. But boy, do I hate the fact that the camera moves. Because really, isn't the player's moving too, right? When we rotate the camera, or when we rotate, oh no, it's looking in the direction that we walk. Yeah, I would never put look at on the camera. It's so weird. Oh great, they fix it. In this last line here, we're going to replace the line where the vector 3 move gets calculated. So we're gonna do all this jazz, and we're gonna go over here, and on player movement here we should be able to replace that. All right, so now if we go and play, all right, so we're here gonna split my game and my scene window. Also, there's another little trick you might not know. If you click on a game object in your hierarchy, hold shift and press F, and you can zoom out with the scroll wheel, it will now follow that game object in the scene view. It doesn't always work, but it should. See, look, it's working now. All right, great. So now it is now moving the player where we're looking, but only when we're moving. I think I can dig that. I actually kind of like that. So I'm allowed to free look around. I mean, it's kind of weird that my character is not looking around with me, especially for a multiplayer game, but that could always be adjusted later. But then, like, if I come over here and I want to look that way, all of a sudden it snaps and I'm looking that way. So it ain't bad. Ain't bad. One real quick thing that's not part of the tutorial, but let's just come in here because it's annoying. And let's go to our prefab player capsule. Let's find our glasses, and I do need to make that a different color. Let's go ahead and let's make it black. Material, black. Also, I would never use a bunch of multiple materials. I'm a huge fan of using texture atlases and like UV mapping things so you can have a single material for multiple game objects. But there we go. Cool sunglasses. And then this cube, I'm just going to put on a layer called don't render for camera. All right. Invisible to camera. Oh, wait, I can't do that. Can't do that. Oh, snap. You know what I'll do instead is, the reason I can't do that is because it'd be the same for all players. Oh, I didn't save. Oh, I should have saved. Oh, go back. At least I still have my material. I still got my material. Put it on there. All right, save. Go back. Oh, we were doing so good. We were staying right on task and on time, and now I'm distracted. But if we hit play, all right, start shared client. And if we like look at our glasses, right? And then I need to go over here. And if we go to the main camera and what am I looking for? Clipping planes near, we can just make that a little bit bigger and boom. So let's say 0.8. So now stop play mode and I'll set my clipping planes to 0.8. Oh, but that means we won't see the floor though. Wait a minute, let's just see what happens whenever we actually start the shared client. Oh yeah, we can't see the floor now. So let's undo. We're just gonna leave it for now. We'll save it for a future episode possibly. All right, so that brings us to the bottom of this page, right? So in the next episode, we get to look at some network properties, probably like network syncing variables and whatnot, like names and such. So that should be fun. So until next time, don't forget to like, comment, subscribe, and we'll see you later. Bye.